Well, good morning. Can everybody hear me okay? I'm Michael Jennings. I work for Lawrence Berkeley National Lab, and I'm the primary developer of a tool called the Warewulf Node Health Check. Some of you might remember me from MoabCon. I gave a presentation there. If you're wondering if this is going to be the same, well, yes and no. I'm going to go over a lot of the new features that just came out within the past few weeks, and I brought along a colleague of mine. She's not a developer of the script, she's a user of the script, and I thought you might like to hear from somebody who's actually making use of it on a day-to-day basis rather than just hearing from the guy who wrote it. He might be a little bit biased. So I'd like to introduce Jackie Scoggins.
Welcome everybody, and thank you all for coming out to listen to us talk about the Warewulf Node Health Check. As Michael mentioned to you earlier, my name is Jackie Scoggins and I am at Lawrence Berkeley National Laboratory. One of the things I wanted to talk about is what is NHC and why do we use it? Node Health Check was something that was referred to as a hook off of Torque. It was something that can run before jobs start, something that can run after a job has completed. It performs things to check for failure of nodes, so it can offline a node in PBS and making sure that jobs did not run if there were certain things that you were checking for that would prevent the node from being healthy. So one of the things we noticed is that Torque imposed no restrictions and blocks until script completion. So it basically would run and wait until everything was completely finished before it would release it. So Michael developed Node Health Check a little bit on that premises, but it's a little bit better in a little different ways. So why do we use it in our environment? One of the things I liked about it was the fact that we were running over about 1,500 nodes with 21 computational clusters, 300 jobs daily that are going in and out of the nodes in 15 different departments, and over about 40 queues. I manage the scheduler at the site. So we have this thing called a super cluster, super computing environment, where we have multiple departments that are individually owned and they purchase them themselves, and they actually have their queues set up for their own environments. And then we have our own environment that we purchase our own systems from, and we set up queues basically to share amongst the environment of users who needed to have computational resources. One of the challenges was keeping track of nodes and why jobs weren't starting, and when jobs did start, what was causing the jobs not to actually complete, or failures that would happen. And one of the things that I liked about Node Health Check, with managing over 1,500 plus MOMs, as everybody knows PBS MOM, if you're familiar with Torque, that's the resource manager server, and it can check to see if the nodes are available, it checks to see what resources are available on the nodes, and it helps the scheduler like Moab decides where the nodes would be, the jobs would be best to fit on the node. Well, there are times when you may have issues with a node that you may not catch. Like for instance, if tip is not mounted because the disk failed, or if the local scratch space that you have out there is no longer full. So there are things that we found just on 1,500 nodes. It was kind of complicated to keep track of and keep monitoring. So Node Health Check actually in our environment helped alleviate a lot of these problems. We have over 30 network mounts. We have Linux NFS. We have a Lustre file system. We have local individual cluster departments who bought I/O devices for their own selves so that they can put data onto their systems. Am I still running? Okay. And basically, it became more of, however, it was individually architect and how it was globally architected, we had to manage all of this. So we have over 30 different distinct node types as well. So one of the benefits that I found, it was simple and it was modular for Node Health Check. I mean, basically, I'll get on this on the next slide. All you need to really know is Bash. And that made it so much easier. It was easy to track problems, and one of the things that the Node Health Check problem does, the script does, and Michael will explain a little bit more in details, is that it will give us a message on the nodes of why that node is no longer online. So we know when we go look at PBS nodes minus LN, it'll give us a message stating the reason why the node is not online, and that actually helps a lot. We can monitor items globally and on a per node or per group basics. Like I said earlier, it could be for CPU problems, it could be RAM, swap, file system, processors, whatever. But the system, we can see exactly what the problems are because we have individual checks on the nodes that will actually let us know what the problems are. It was very easy to use. He builds the scripts, he provides you with them, so you can immediately start running off with CPU checks, processor checks. You can start off with file system checks, whatever it is that you need to do within your environment. So it was really, really simple. And another benefit of this is he's right across the hall. I could just go knock on the door, but I never have to ask him for any questions because it's very simple, like I said earlier, to actually get involved in it, to get it started. One of the reasons why I think you should use it is that it is easy to deploy, it is easy to configure, and it's very easy to use. How many of you guys use a scheduler at this present time now? How many times have you heard users call up or users get on a node, their jobs start running and the file system went out from under them and they weren't able to write at that very last minute and that job bombs or crash? I mean, it's to the point where more jobs may come on because this may happen over a weekend, it may happen at night. You're not there, you're not present, so the nodes are still actively running because PBS knows and PBS mom thinks the node is alive. There's no reason for it to think because the file system's off, PBS mom isn't running because it may be on a different file system. Well, we charge at our job. We charge for processing for people to run on our system, and it's a pain to have to refund people when you don't need to. And so one of the benefits of having Node Health Check is that it's monitoring, it's watching, it's our eyes and ears and our everything is touching the system, and it's actually making sure for us that there are no real problems that we can't address and that the nodes won't start jobs and fail. So it prevents us from having to refund jobs. It prevents us from having to explain to the user why their job crashed at the end of a 200-hour run or 80-hour run or a 24-hour run. It just depends. It's easy to diagnose these things for the user so that they know why their jobs did not start. It automates common troubleshooting, so personally we can focus on other solutions, other problems, like looking at other things that may be needed on the system, improving our queues, setting up different environments that we may need to do. And there's no need to monitor multiple nodes and catch a problem one node at a time. For me, that was made it much easier and much simpler to use. And I think that's my last slide. And now what I want to do at this present time is I want to introduce Michael so he can go into depth of what it is that NHC is about. Okay? Thank you.
Oops, sorry. So I wanted to start by going over some of the new features that have recently been added. When I spoke at MoabCon, we were using 1.1.4. I have now released 1.2, and since then I did a bug fix update, so 1.2.1 is now current. 1.2 was a pretty big change. One of the most fundamental changes that I did was I went back and I refactored large portions of the script itself as well as the underlying checks so that I could write unit tests for all of them. If you've ever written a large program or even a small program, you know that fear of, I changed this little bitty thing, what's going to screw up? Have I messed something up for somebody else's system? Have I made a subtle logic error that I won't catch but somebody else is going to catch? So the unit tests allow me the ability to run through all of the checks that I've written in lots of different little corner cases to make sure that the expected result matches up with what I'm actually getting, so I don't have to worry too much about subtle breakage. I also added support for defining variables inside of configuration files. Before, if you wanted to change settings, you either had to edit the script or you had to go in and set up the environment in advance. You don't have to do that anymore. You can put environment variables in the config, and you can use the same matching syntax that we'll talk about a little bit later to define which nodes get which variables. I added a lot more variables, a lot more customization that you could do. And I added support for NVIDIA HealthMon. You may not have heard of this. It's actually quite new. NVIDIA has just released the development version of their TDK, their Tesla Deployment Kit, version 3.304.3, if memory serves. And they included with that a script called NVIDIA HealthMon, which goes through and does a whole bunch of very in-depth checks on their GPUs to make sure that everything's working properly. And we have support for that now. I added something called Detach Mode, which a lot of you might be interested in, but I'll go into depth on that later. I added some disk space checks and a process blacklist. One of the checks we have allows you to look and make sure that a particular daemon is running. This blacklist allows you to make sure that something is not running, like, say, rogue SSHD processes for users who shouldn't be on the node. And 1.2.1 was mostly a bug fix and cleanup release. I had a guy named Ole, I think is how you pronounce his name. He contributed several things, including a log rotate script and a cron wrapper for us. I fixed some problems. I don't know if you've ever noticed, done a PS. If somebody has a user ID that's longer than 8 characters, it shows up as a number, even though it was able to resolve that UID to a user ID, it still shows up as a number in PS. And we try to enforce an 8-character limit for that reason, but you know how users are. That doesn't always happen. So I added some code that would actually detect that and go back and resolve the user ID so that things like the job checks for authorized jobs and authorized users would actually, work. Ole also found a bug. We do the notes in PBS nodes a little differently for most sites. We consider a missing note. If you don't leave a note, we just assume that you didn't actually want to offline that node. We require notes if you're going to offline a node, and so it treated no note as if it could just take over handling of that node. Well, in his site, they don't use notes the way we do, and so he would offline a node for testing, and Node Health Check would come along and say, oh, that node looks fine to me, I'll put it back in service. Obviously, that's not what we want. So I took care of that. And I also added a variable for authorized users on the node. We have a lot of sysadmins and user services personnel who make use of that. So there's a lot of new features. I wanted to go over the configuration file syntax in case you haven't seen it. It's actually very flexible. You can take one configuration file and use it across your entire cluster, whether you have homogeneous nodes or whether you are like us and you have over 30 different types of nodes under one umbrella. You can still use one configuration file and handle all of them, because at the very beginning of each line is a match. You can match using a wildcard, or you can match using regular expressions. Either one will work. And you tell it which nodes you want it to run the check on. Or in this case, I added this to specifically call out the fact that you can do variables in the same way. So up here, star obviously means everything. The double pipe is your delimiter, and then everything on the rest of the line is your check. Now, a check is just bash, so you can do technically anything you want to. But here we're setting variables. Max sys UID I'll talk about a little bit later. This is a fairly obvious one. If I have utilities for torque that I want to add to the path, or the HealthMon script, if it's not in my path, I can change the path in that way. And then I have some basic checks. This one makes sure that there's a root-owned SSHD that's running. If you use your system in such a way that you have not disabled the killer or disabled overcommit in the kernel, you've probably experienced the kernel coming along and killing your SSHD, and suddenly you can't get into the node. Well, obviously that's not a node that you want to have running jobs anymore. But if you're using if you have TM support, Torque is still perfectly capable of executing jobs even though SSHD is gone. So we flag that and we offline those nodes to make sure that if the node has been run out of memory and could be in an arbitrarily bad state, we definitely don't want jobs running anymore on that node. I have checks here for different types of processors. For our Nehalem systems, we have 2 physical sockets, we have 8 cores, and then we don't use hyper-threading, so we also have 8 threads. The HT is for hyper-threading. If you turn on hyper-threading, you'll get twice the number of threads that you have cores. And then the Westmers use 12-core processors, so we can delineate by the name of the node which number of CPUs or sockets or cores we're looking for. And then the bottom is just to illustrate a regular expression check, and we're looking for a certain amount of physical memory. You can check for a minimum and a maximum. You can leave either one blank if you want. Obviously, if you leave the first one blank, you better put quotes in there to make sure that it's not, that Bash doesn't interpret it as the first parameter rather than the second one. So as I said, I added a lot of variables that you can customize now. I wanted to point out some of them in particular. Path, fairly obvious. We start with the secure path, bin, user bin, sbin, user sbin. If your torque installation is not installed in the default prefix, you might need to change that. There's a couple ways you can do it. You can either define your path, or you can specifically set the direct path to like your PBS nodes command. So all of your executables that you use have variables now to define where they're located, so you can set that variable, or you can set your path and just leave the default, which doesn't have an absolute path. Mark offline is a big one. If you can set your PBS mom to mark itself down if there's an error. If you prefer to use that, you might want to turn this off. If you set mark offline to 1, which is the default, it will actually go and set the node to be offline in torque, and will set a note on that. I don't know if you guys have ever used the notes within torque, but you can assign a little string to each node and tell why it's in the state that it's in. And Node Health Check uses that capability extensively, so that, as Jackie said, you just run pbs nodes-ln, and it gives you a big list of all of your nodes that are down or offline, and it shows you which ones Node Health Check offline and why. So it's very easy to get a quick overview of your nodes and the state that they're all in. I talked about this a little bit before. We have user services personnel and admins who may need to run jobs on any arbitrary node at any time. We're getting ready to activate the kill feature of one of our checks that will actually terminate processes for users who are running on a node and shouldn't be. We have a couple of pieces of software, QChem being a big one, that likes to leave processes lying around after it exits, and our users are all too happy to get the extra free time, but Jackie said we charge for that, and so we can't really allow users to run over their wall clock time, especially since they're probably going to be interfering with other users. So we're going to start killing them off, and in order to do that, we don't want to be killing ourselves off. That would, be bad. And so I added support for this variable so that we can put all of our user IDs in there, and it'll leave our processes alone. PBS nodes just allows you to give a direct path to that executable. Timeout. One of the features of Node Health Check is that it has a watchdog timer. When Torque executes the Node Health Check, it is single-threaded and it blocks until that process returns. That's the reason that NHC is written the way that it is, to try to minimize subcommands and to try to be as fast and efficient as possible. But there's also a watchdog timer, so that if, for whatever reason, the script gets hung up, this will kill it off. So your PBS mom will not block forever and ever. If you have a lot of checks, especially a lot of the checks that require subcommands, there aren't very many, but some do, then you might want to set that a little bit higher than the default. I believe the default is 10 seconds. You might want to bump that up a little bit. But in our experience, for all of our nodes, things tend to finish in about 1 to 3 seconds, give or take, depending on how heavily loaded the node is. And then we write a log file as we run to tell you which checks we're doing and which ones passed, which ones failed. If you have, like if your root file system is in memory, if you boot stateless and you have a limited amount of memory on your nodes, you may not want to be logging to the default of var log, which will probably be on your root file system. So you might want to turn that off. So as you can see, we have a large number of existing checks. I'm not going to go through all of them. I did want to call out the one new one for blacklisting a particular command. You can specify the name of the command and any arguments, and you can specify an optional owner. And with this one, you can actually negate that. So I mentioned earlier, you might want to check for SSHD processes that are owned by a user rather than root. And using that exclamation mark root is how you would do that. The new stuff, we have a lot of disk space checks. The downside of using these, and I'll say this right off the bat, it has to run the df command in order to get that information. There isn't really a reasonable place in proc. I use proc very heavily, but there isn't really a place in proc to get that, at least that I know of. And so it has to spawn df. If you've used a lot of NFS file systems on your clusters, you know as well as I do, there's a risk that df will hang. So keep in mind, if you use any of these checks, there is that risk. Now, I've done two things to mitigate that. One thing is, once you use one of these checks, you're done. The df command will read all of your file systems, get all the information, and store it in cache. So once you've used it once, you can use it 100 times, and it won't make any more difference. The other thing is detached mode, which I'll get to in a little bit. So the checks are basically self-explanatory. One interesting thing is you can specify the sizes as an absolute number of kilobytes, or you can specify it with a suffix, either like G or GB, either one works. Capitalization doesn't matter. It'll parse all of that stuff out for you. Or you can specify a percentage. If you want to look for 95% full or 98% full, or you want to leave at least 5% free, all of that stuff works as well. Are there any questions so far? Okay. I wanted to specifically talk about NVIDIA HealthMon. A guy named Robert Alexander worked on that with NVIDIA. He came to a conference that our IT department put on. Nice scarf, by the way. Bernard introduced me to him. He was working on this GPU health check, and Bernard was like, oh, hey, we're working on a node health check. Maybe you guys should talk. So we did, and we're collaborating on support for this, which we currently have, and additional support going forward to help customize the way that the HealthMon script reports back. Right now, you basically execute it, and it runs through a whole series of checks and gives you human parsable output at the other end. If it succeeds, no, there's no problem. It's obviously a pass. If it fails, we currently don't have a way to get explicitly what the problem was. So what we're doing right now is, if it fails, we'll give you a message that the NVIDIA HealthMon failed in the note, and the entire output of the HealthMon run will be output to the NHC log file, so you can go back and check and see exactly what failed. But it's fairly straightforward. It doesn't really take any parameters. Just check NV HealthMon. It'll run and return back, hopefully, success. So, detach mode. I believe it was Brock Palin from the University of Michigan had brought up the idea a while back about having a daemon that runs in the background and does all of the health checks separately from your PBS mom, and then writes the results of those checks to a file, and then your health check script would just come along and check the status of whatever happened. Well, while that would work and is a good idea in some respects, having yet another daemon running on the system, especially for clusters where you have very tightly coupled jobs, you don't necessarily want to incur the additional OS noise of having a daemon sitting around running checks all the time. So I tried to come up with a way that NHC could support that type of a mechanism, but without the added overhead of another background process, another daemon running all the time. So the idea I came up with was Detach Mode. What Detach Mode does is it basically forks the process as soon as it's done setting up the environment. The first thing when it runs, it reads etc sysconfig nhc. That's the file where you have to turn on Detach Mode, because by the time it goes to parse the config file, it's too late. So you have to turn Detach Mode on there. If you turn it on there, once it's parsed that file and finalized the environment, it will go and it will read the state file from the last run and then immediately fork. Then the background version of the script will go ahead and do all of the checks that you have configured, parse the config file, run all the checks, do all of that work, all in the background. That way, the window in which your PBS mom might block is as minimal as possible, well under a second. Then, the foreground process, all it does is take the result of the last run and act on it. It'll offline the node or return success, whatever the state was from the last time around. It handles that and it's done. So it's very quick, and all of the heavy lifting, things like DF that might block, happen in the background. And once that's finished, it writes the state file and exits. So you're incurring essentially the same amount of OS noise that you would just running the health check by itself at whatever intervals you've configured, whatever time frame you configured. The OS noise is the same. But you don't have to worry too much about blocking your PBS mom and having it lock up on you. There's one caveat with Detach Mode that I have to point out. If you have Node Health Check set up to run at job start and at job end, and only at those two times, keep in mind that the results that NHC returns are from the previous run. So if something happens to your node between jobs, a job is about to start, and NHC runs, if the last run was successful, it'll return success, even if something has gone wrong in the meantime. So if you use Detach Mode, I highly recommend you test at job start, at job end, and some time interval in between to try to help your chances of catching a problem before the job begins. How am I doing on time? What time is it? Okay. So I believe Adaptive is going to make these slides available. I have just some tips in here about how to write your own checks. There's extensive information on the website about how to write your own checks. So I'm going to go through this kind of quickly. Because of the situation that we ran into with the host name, when NHC runs, the host name that it uses for all of the matches and all of the actions like offlining the node is whatever is returned from the hostname command. Or it's actually technically that file, but whatever hostname would return, that's what it uses. We had a user who has an environment where that hostname and the hostname that Torque recognizes the node as differ. So if you're in that scenario, you might want to set hostname to this. That's a built-in variable that we have, hostname _ s. You might want to set hostname to that to make sure that your Torque hostname, or set it to whatever your Torque hostname is, to make sure that offlining works. And this is just a very efficient way to get the last part of your hostname as opposed to the first part. We use that for our cluster name. So if you need to use the cluster name for any of your matches, that's a good way, an efficient way to get it. That's all I have. If you'd like more information, I've got the URLs up there. The documentation page is very extensive. It goes through every single check that we support. It talks about all the arguments and what each one does. There are example configuration files there. Lots of the bash tips and tricks that I used for making sure that I don't have to fork and run sed and grep and awk and all those subcommands that can take time and potentially block. I use native bash absolutely as much as possible, so you'll find some very interesting code constructs in there. So all of that information is in the documentation page here. If you're interested in using it or potentially contributing, I encourage you to check out the Torque mailing lists and or the Warewulf mailing lists. They're all fair game. And if you have any questions, I'll be happy to answer them for you.